first exercise. So yesterday we have studied about parity check. So let me tell you what is really parity check. Parity check is an error detection method where you normally add one extra bit to the byte being transmitted. And there are two schemes that can be used for parity checking. One is even parity and the other one is odd parity. So for example, here you can have a question. Parity checks are often used to check for errors that may occur during data transmission. The system uses even parity. Now what you will need to remember is, since the system is using even parity, if a byte has been correctly transmitted or received, it must have an even number 1. Let me do the first one. Okay, here you're supposed to tick to show whether the following 3 bytes have been transmitted correctly or incorrect. So if there are even number of ones, therefore it has been transmitted correctly, otherwise it will be incorrect. So for this one, I count the number 1, 1, 2, 3. So as you can see, there are 3 ones here. So 3 is an odd number and it's not even, therefore the byte has been transmitted incorrectly. Okay? Try for part number 2 and part number 3. So for the second byte, if you take a look here, the number ones in this case is 1, 2, 3, 4, 5. Therefore, there are 5 ones again. In this case, 5 is an odd number and not even. Therefore, the byte has been transmitted incorrectly. So, in case we're using even parity, you must ensure that the number ones present in the byte is even or odd. Yes, for the third part now, 0, 1, 1, 0, 1, 0, 0, 1. In this case, I have 1, 2, 3, 4. So there are 4 ones in this case. Since there are 4 ones, therefore it is even. Okay, 4 is an even number. An even number is one that is exactly divisible by 2. Therefore, the byte transmitted has been transmitted correctly. Okay, this is one type of exercise that you may get for parity checking. Okay, let's look at this exercise now. So, if you have followed the class yesterday, we have discussed about the concept of a 2-dimensional parity checking. Okay, in this case, how do we proceed by answering this exercise? So you're going to go by rows. Each of these rows here, 1, 2, 3, 4, 5, 6, 7, and count the number 1. As you can see, the following block of data shows all 10 bytes received after transmission. The system uses even parity and the column 1 is a parity bit. So in order to identify the byte number and the column number which contain an error or which has been transmitted incorrectly, as a question first part asks you, one of the bits has been transmitted incorrectly. Write the byte number and column number of this bit. So if you have this type of question, you should proceed this way. Okay, for each of the rows, you calculate the number ones that we have. 1, 2, 3, 4, and I know down 4 here. In this one, 1, 2, 3, 4. Third byte, 1, 2, 3, 4, 5, 6. As you can see, these are already giving me even number ones. Therefore, the following are even parity. This one, 1, 2, 3, 4, 5, and then 6. So there are 6 numbers of 1. Okay, so you'll have to go for each one of them. So I'll give you a few seconds to complete for number 5, 6, 7, 8, and 9. How you're supposed to proceed. You count the number 1 for each word. So here is this one I have 4, 4, 6, 6, 4, 2, 3. So as you can see, it's byte number 7 that normally have an odd number of 1s. Therefore, I'm going to draw a line on byte number 7, which is this one. Okay. Now I will need to find for the bit now. So I go by column now. Okay. So for each of these columns, you are going to again compute its number 1. So 1, 2, 3, 4, 5, 6, 7, 8. So it's even. This one doesn't contain any zeros or 1, so we'll just omit this one. This one, as you can see, 1, obviously 1 up till 9 is going to give us 9. 1 plus this one, 10. Okay, this one, 1, 2, 3, 4. Therefore, there are 4 ones here. Now, if you observe 1, 2, 3, 4. Okay, and this one, 1, 2, 3, 4, 5, 6, 7. So this is the only column that contain an odd number. 8 is an even number, 10 is an even number, 4 is an even number, this one also is an even number, 7 is an odd number. You can try to compute for this one, 1, 1, 1, 3, 4, 5, 6. And for this one, 1, 2, 3, 4. In this case, this gives me 4. Now, if you observe now, this column has an error. You're going to draw a second line, and then you're going to see it's going to intersect at a given point here. Right? So this is my intersection point. Now, it asks you in the question, what is a byte number? Okay, what is a byte number? So as you can see, but the byte number is 7. And what is the column number? 6. So this gives us the answer. So as you can see here, given a question like this, first you need to compute for each bytes in terms of rows here, how many ones I have, and then you just find out which one contains the odd number. You draw a line and then do 4 columns. Okay, now some of you might be confused. Should I count the parity byte in this? Yes, as you can see, I have counted 1, 2, 3, 4, 5, 6, 7, 8, including the parity byte. Okay, so that's the second exercise that you may get in array detection. Let's look at a third exercise. When data are transmitted from one device to another, a parity check is often carried out on each byte of data. The parity bit is often the leftmost bit in the byte. If a system uses even parity, gives a parity bit for each of the following bytes. So here you're supposed to fill in either a 0 or a 1. Whenever you get a question like this, you underline important points first. First, I'm using even parity. And the leftmost bit, so leftmost, left and then right, the leftmost bit obviously is this one and this one. Again, you just count. Since we're doing even parity, there must be an even number 1. Now, there's only 2 possibilities. Either you put a 0 or a 1 as an answer here. Let's say randomly I choose to put a 0 here. What will happen in terms of answers? Is it correct if I'm using even parity? Since I'm using even parity, if I count the number of 1s here, there must be an even number of 1. So 1, 2, 3, 4. So my answer is correct. But basically how you answer this is you count the number 1 first. 1, 2, 3, 4. And then you question yourself, is it already even? Yes, it's already even, so I don't need to add a 1. If I add a 1 here, it's going to be odd. Therefore, I should add a 0. Here, if you count, it's odd. Right? There is 1. 1 is an odd number. Now, I need to make it even. So I can't add a 0 here. It will be still only one number 1. Therefore, in this case, I add 1. As you can see here, 1, 2, in this case, says even number of 1s. So there are 3 possible questions that you should take a look when you are working exercises on even parity, odd parity, or parity check. First, you're supposed to know about the theoretical part. What is parity checking? Parity checking is where we add an extra bit using either the even scheme or the odd scheme. Okay, and what are some of the limitations of parity check? Yesterday we have seen it. Some of the limitations of parity check is that when 2 of these bytes, 2 of these bits has been swapped, it won't be correct. So refer to yesterday's lesson, and this lesson 2 is being recorded and will be sent to you afterward through Google Classroom.